So this video is a review of solving linear and quadratic equations. So equations that are linear and quadratic in nature. So we have our linear equations. Our x's do not have any exponents. And here we have our quadratic. So the leading term is an x squared. When you multiply this out, you'd also have an x squared. So let's start with linear. So with linear, there's 3 steps. Number 1, you want to simplify the equation. So that means to distribute. Combine like terms until you get down to your basic equation, which is just the number of x's we have, 3 x's and a 10 are 2 different terms. So we do the same thing to the other side. And there we go. So that's number 1. Number 2 is we want to separate. So we want our x's on one side. So if we add the 2x here to both sides, and then subtract the 10 from both sides, we now have it separated. X is on one side, we have 5 x's over here, and our constant on the other. And then the last step is to divide. You divide by whatever is next to the 5, because we want to find out what x is. So we divide both sides by 5, and there we go. So x equals -8/5. So using these 3 steps will always allow us to solve it. This works every time. So with our fractions here, one of the things to simplify is to remove fractions. So anytime you have fractions, you find an LCD. So our denominators are 4 and 5. 4 times 5 is 20. We need a number that both of them will go into, and again, least common denominator. So we want it to be as small as possible to make the numbers as small as possible. So this would be 20 divided by 4, which is 5, times 3. So 5 times 3 is 15. So you're just distributing it. We're introducing a number to both sides that we can distribute. So 20 times 1 is -20. And you can even do top first. So this is 40 divided by 5, which is 8x. So it's 20 times 20 divided by 4, which is 5. Times 3 is 15, or you could do 20 times 3, which is 60, divided by 4, which is 15. Same thing here, 20 divided by 5 is 4, times 2 is 8. Plus, and then we get 40. And so now you'll see there are no more fractions. So that is part of the simplify. So our simplify here also involves common denominators. All right, now we just separate part 2. So we're going to move the 8x over. And you can even do this all in one step. So now we can add the 20 to the other side. So we're moving the x's from one side and the constant from the other. And that ends up with 7x equals 60. And then the last step, number 3, is divide. And we get 60 over 7. You can write these as decimals or mixed numbers, but 60 over 7 is the answer. All right, so anytime we have that situation where there are no exponents on the thing we are solving for, that variable, we want to use these 3 steps: simplify, separate, divide. It's what we're doing to each side. So we're multiplying to remove, adding or subtracting to remove, and then dividing to remove. We eliminate as we move down equation. Now quadratics are different. Quadratics we have to use factoring. So the first step is to set equal to 0. So 8x squared minus 10x, and then this just means to subtract the 7 to the other side. And then we try to factor first. If that doesn't work, we use quadratic. So number 1, factor, or quadratic formula. So there are a few ways to get there. You can just go straight for it. And so this is 4x and 2x, and then minus 7 plus 1. And then we would check it as 8x squared plus 4x minus 14x, which is -10, and -7. Or we can use the trick method. 8 times -7 is -56. So we need two numbers that multiply to give us negative 56. When added, give us 10, and that would be negative 14. So it's negative 14 and 4. And to find these numbers, all you have to do is a quick little list. 1 and 56, and you move down to 2. 2 and 28, and then 3. 3 does not go into 56, so there's nothing. And then 4, and it would say 14. And one of them has to be negative. Since the middle number is negative, and it's a negative 10, we know that the larger is the one that's negative, and there we go. That's the one we want. So now we take our x, and we subtract 14, and we take our x and we add the 4, but we have an 8 in front, so we divide each one by 8. Reducing this, we get x minus 7 over 4, and x plus 1 over 2, and then we move that number right back in front. So this is 4x minus 7, and then 2x plus 1. And then we put our equal 0 back on there. So again, you could go straight forward if you're good with guess and check. That's the best way to do it. And if you're not, you can use the trick method like this. All right. And then now once we have this, we now use the zero factor property. So that's in the step 3. Set each factor equal to 0. So 4x minus 7 equals 0. 2x plus 1 equals 0. See, what's happening is that we're trying to make two numbers that multiply to make 0. So if you factor this, we get to use our zero factor property. So if this one was 0, the first one, the 4x minus 7, if that's 0, then 0 times 2x plus 1 would be 0. And if the 2x plus 1 is 0, then 0 times this would be 0. All right, and then that allows us to turn it into two linear equations, which we can now use this. So all you're really doing with quadratics is factoring it so that you can have a linear equation and follow these 3 steps. So now we have our simplify, separate, and divide. So that's all this is a trick to turn it in. So to separate this, we have to add 7 to both sides. So we get 4x equals 7, and then divide by 4. And we end up with x equals 7/4. That's one solution. And then we do the same thing over here. And so we end up with 2x equals negative 1. Divide by 2. And we get x equals negative 1/2. Those are our two solutions. So since we have an x squared here, this is a square, there's going to be two solutions. Now they could be the same number. We could have negative 1/2 and negative 1/2, but you will get two linear equations that you can solve to get two answers. All right, on the next one, this one's not factorable. You can even see it's 1. So if we tried that little x thing, we need two numbers that multiply to give us 1 when added give us 10, because there's no number in front. See, over here we did 8 times negative 7 is negative 56. But here it's 1 times 1 is 1. There's no numbers that you can multiply to make 10. So we know that factoring is not possible. This is not factoring. So we go into quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, it's the negative boy right here. This is the negative boy, couldn't decide. We go to the radical party, where the square bouncer removed 4 alcoholic cans and it was all over at 2 a.m. That's how you can remember it. Or you can use Pop Goes the Weasel online. But we write this as ax squared minus plus bx plus c equals 0. So if you write that quadratic right below it and see how it says equals 0, that's why step 1, set equal to 0 works no matter what. You have a square, you set it equal to 0, except for this one. This one we'll do differently. All right, and now you can see that our a here is 1. Our b is negative 10. And our c is positive 1. So now we just have to plug them in. So x equals negative. Make sure you put parentheses for every variable first. And then we substitute. So let's do green. So our b here is our first one, and that's negative 10. And we'll put negative 10 there as well. And then a, I'm going to increase the font here. So negative 10, negative 10. And then this is our a. Our a here is 1. and then this is our c. So our c here is 1. The bottom is also a, and a is 1. So it's just plugging in and simplifying. So far what we have is x equals positive 10 plus or minus this. This is our radical, so it's going to give us real or rational solutions, or imaginary too. And then 2 times 1 is 2. So real, rational, so real solutions or imaginary, so rationals, irrationals. So we want to figure out what that is first. So you want to start by just doing the square root by itself. And this is always squared, always positive. So negative 10 squared would be 100. And then you want to decide your sign. So you look at each of these and you see, okay, well, negative times a positive is a negative. 4 times 1 is 4. So now we have a nice radical that's separate from our entire expression. 100 minus 4 is 96. And then we can simplify the 96. So 96 is made up of 2 and 48. And that's 2 and 24, which is 4 and 6, which is 2 and 2, 2 and 3. So we have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s, and a 3. And we take out our pairs. So we have a 2 times a 2, and that's it. So we end up with 4 square root of 6. So that is what goes here. And now the next step is just a little simplifying. So we want to separate them. So 10 over 2 plus or minus 4 rad 6 over 2. This is a division. It's all over 2, so they're both being divided by 2. We end up with this. So 10 divided by 2 is 5, and 4 divided by 2 is 2. Remember, you can't go inside that radical. They're inside. They don't come out. The only way to get into a radical is to be in a radical. And there is your solution. So it was irrational. That's why we could not factor it. All right, and then the last one. This one is the square root property. So anytime you see x and there's only one of them, but it is being squared, what you want to use is a square root to remove it. So you want to, number one, make sure it's isolated. And then you square root both sides. Now when you square root, it is going to introduce a positive and a negative solution. So we end up with x plus 4 equals plus or minus square root of 50. If you want to know more about why that is, you can watch the quadratics square root property video. This will simplify the same way we did over here. So this becomes 5 square root of 2. And then here's what you do with that 4. So this is now our linear. See, we've changed this into a nice linear, and we have our 2 solutions sitting right here. So when you subtract the 4, you're going to have to subtract 4 here. You just place it right in front. So we're always going to have this type of situation. We have our number plus or minus our irrational or imaginary. So we end up with x equals negative 4 plus or minus 5 square root of 2. There are 2 answers. So if you want to, you can also split them. This is negative 4 plus 5 radical 2 and negative 4 minus 5 radical 2. Your choice on the solutions. This works, by the way, with anything with a square. So here's a little side extra one. If we had x squared minus 3 equals 5, then you would want to isolate it, separate them just like we've done any equation. And you can tell you're not using quadratic formula or factoring here because there's only one x squared. You see how we have just x squared. There is just x squared. If you look at the other ones, we have an x squared and some other x squared and some other x, just x squared. Just x squared is square root property. This also works if you have a cube or a cube root or any others, it's just the x. All right, and then now we can square root plus or minus to remove that. And if you, again, you need more on these, you can watch the square root property. Plus or minus 2 radical 2, and there we go. So these are all the different equations you're going to be running into that are linear and quadratic in form. So if it's linear, we do separate, simplify, separate, and divide. And if it's a quadratic, you're going to do factoring if possible. If factoring doesn't work, you will then use quadratic formula. And if there is just one visible x that you see, I mean, obviously there's a lot more x's. If you were to multiply this out, it would look like this. But you see one physical x, like just if you were a 5-year-old looking at this and you said, how many x's are there? They would say 1. Then you would use square root property. 1. So you use square root property. Make sure you always isolate because we need that isolation to cancel right here. Think of it like a little battle. If you had to get to x, you first have to remove his guard. So we have to take out the guard. Perfect. Now he's alone. And we have to break down his door to get into him. And so now we broke down his door. So we got the guard, got rid of the guard outside his room, and then we killed off the door. And now X is all by himself and we can get to him. All right, thank you.